this time. Okay, I'm going to give everyone 2 minutes to pop on, and then I will start. We are doing functions and graphs, page 143. Is it better with the lights on or with the lights off? Can you see the board? Or no? That's pretty good. Cool. Good morning, grade 10s. Only a few of you today, but it's fine. I'm going to post this on YouTube and on the Google Classroom. So can you guys hear me? If you can't, just type a message in the chat, okay? So we're going to work on functions and graphs today. Cool. So the first thing we're going to do is go through an example. In the last lesson, we did function notation, which was instead of using y, we're using f of x. Okay. So our first question is this one here. Okay, so we have g of x is equal to negative x over 2 plus 1. Okay? And they want us to calculate the values of g of negative 2, g of 0, and g of 2. Remember, normally we use f of x, but we can use any letter. So now we're using g of x. Okay. So what this g in brackets, negative 2, means is when x is negative 2, what is y? So let's see. We're going to just replace our x from our original equation with negative 2. So we're going to get negative 2 over 2 plus 1. Okay? Negative 2 over 2 is just going to give us negative 1. Negative 1, our two negatives make it positive. So we get 1 plus 1, which is equal to 2. So g of negative 2 is equal to 2. If we wanted to write that as a coordinate, we could. We know what our x would be. Our x is negative 2, and what we just worked out would be our y. So let's write this in a coordinate. It would be negative 2, 2. Okay. Let's have a look at g of 0. Same thing. We're just going to replace our x with 0, and we get negative 0 over 2 plus 1. We know 0 over anything is going to give us 0, so we get 0 plus 1, which is equal to 1. If we write that as a coordinate, we get 0, 1. Okay? And lastly, g of 2. If we have to substitute it in, we get negative 2 over 2 plus 1. This is negative 1 plus 1, which gives us 0. Okay? So our coordinates there are 2, 0. Okay. Why we need this is because the next question asks us to draw a straight line defined by this equation. So it's the same equation, so we just need to draw g of x. So if we wanted to draw g of x, we need a Cartesian plane first, okay? So I've just drawn a nice Cartesian plane there. We have our y's and we have our x's. Okay, cool. Let's plot the points that we know. Okay, we have negative 2, 2. So we have negative 2, 2, 0, 1. So my x is 0, my y is 1. And we have my x is 2 and my y is 0. Okay, there we go. And then I just have to put a line through them. Okay, obviously a ruler would make it straight, but for now we'll just do an example. Okay, also if we had put our spacing in correctly using a ruler, everything would line up nicely. Okay, so here we have a straight line, and this is our straight line of g of x. Okay, so if we wanted to label it, we can just call it g of x. I don't know if you can see that. I just called it g of x. Okay, that's as easy as it is to draw the straight line of our equation. It's just subbing in points of our line, and then we can draw it. I'm going to be going over a few other ways to draw a straight line equation just now. Okay. The next question with all of these questions says, use the graph to determine x if g of x is equal to -1. So normally we are asked g of something is equal to a function. Now we're saying when is our function equal to -1? So when is g of x, our normal function, equal to -1? So what we can do is we can just write g of x, which is our original function, which is -x/2 plus 1. And when is that equal to -1? So I'm just going to write -1. Okay. So now we're just going to work out our equation. Okay? So we have x/2 plus 1 is equal to -1. Our first thing we can do is we can take our plus 1 over to our other side, so we minus it, and we get -x/2 is equal to -2. Okay, now we have x/2 and -2. So we're going to multiply by 2 over 1 by 2 over 1 to get rid of our 2 at the bottom there. And we get, I'm going to write it over here, don't know if you can see it, we get -x is equal to -4. Okay, and because they're both negative, x is equal to +4. Okay, so now we know what x would be equal to when y is equal to -1. So we know what the coordinate there would be. It would be 4, -1, if we were asked a coordinate. Okay, so when x is -1, yeah, and we can also see that in our graph. You guys heard the bell. Okay, cool. So if we were to look at when y was equal to -1, x should be equal to -4. What did I do incorrectly there? And it's equal to -1. Subtract 1, -2, -4. When x equals 4, y should be -1. Yeah, it does make sense, sorry. Okay, if we were to look here, when we get to y equals -1, our x is a positive. Okay. What is our last question? Okay, our last question is to determine the domain and the range of our function. Okay, so let's have a look. If we have a look, we know it's a straight line, okay? If we wanted the domain, remember our domain is our input values, which are our x's. So if we wanted to know all the x's that this graph could be, the graph carries on in one direction and carries on in that direction. So it could be any x value forever and ever. Okay, so the x values of our domain is any real number from the set. Okay, so our domain is x is an element of real numbers. XER. Okay, real numbers are all the numbers that are real. Okay. Then we're going to look at our y's. let's have a look. Our y's, also because this carries on going up and down, it's going to be any value up and any value down. Okay, so our y's are also y, e, r. Y is an element of the real numbers. Okay, so they're both part of the real number set. Okay, so we went over one way that I can draw my straight line, or any kind of graph really. I can just substitute values in and figure out different points, connect them all, and then I have a graph or a function or a straight line. I'm going to quickly go over another two ways of creating a function or a straight line, and they're ways you should recognize as well. I'm just going to move us along. Okay, so our first one is our dual intercept method. Don't know if that helps. Yeah, dual intercept method. Okay, so the dual intercept method is when you are given a function and this function is not going to be passing through 0, because when you're working out your dual intercepts, you are working out when your function goes through your y-axis and when your function intercepts your x-axis. Okay, so when it goes through those 2 points in your graph. And the way we figure that out is by letting your y equal 0 when you want to figure out your x-intercept. And when you want to figure out your y-intercept, you let your x equal to 0. Okay. And then once you have those two intercepts, you can just join the 2 points and continue your line, and you'll have a complete straight line. Okay. Okay. So.
Attention indicators. Please set attendance and temperature readings immediately to the office. Please send attendance and temperature readings immediately to the office.
Okay. So, dual intercept method. You guys have done this before, right? When you have a function or a line and you need to figure out how to draw it, to figure out the x-intercept, you let y equal 0, and to figure out your y-intercept, you let x equal 0. You guys have done this before? If you haven't, send me a message in the chat. Otherwise, we're going to carry on. Okay. The next way to figure it out is called the gradient intercept method. Okay, pretty similar. This happens if we maybe can't use our dual intercept method because a line goes through our origin. Okay, obviously we can't use it when our line goes through our origin because it doesn't have any x or y intercepts. It only intercepts at 0, 0. Okay, so let's have a look. The gradient intercept method, we have to find the gradient first, okay? If our function is given to us in the form y equals mx plus c, if it's given to us in the form y equals mx plus c, we already know what our gradient is. It's obviously going to be the m from our function, right? Okay? And then we use one point on the graph, either the x or the y intercept, or any other point that we know of on the graph. And once we have that point, we can move from that point in the way that the gradient wants to move. So for instance, if our gradient was, I did an example over here on the side, I had y equals 2/3x plus 1, my gradient would then be 2/3. And we know gradient is actually rise over run, or we can call it y over x's, right? So this is actually y's over our x's. So in this example, we have 2/3x plus 1. I am gonna actually just continue this as an example and show you how to do the gradient intercept method with it. Okay, cool. So let's find one point on our axis that we can plot. So I'm going to let my x equal 0. That's my easiest one, because if I let my x equal 0, then I just get y is equal to 0 plus 1. So my y is just going to be 1. Okay, cool. So now let's draw my Cartesian plane. Can you see that? Yeah, cool. So my y is at 1, which means at 0, 1, I have my first point. Okay? So, because my x has to be 0, right? That's what I did. So at 0, 1, I have my point, my first point. And now what I just need to do is I need to move in such a way that my gradient tells me and draw my next point, okay? So my gradient says every time y moves over 2, my x moves 3. Okay, cool. So if I was at 0, 1 here, 0, 1, I need to move my y 2. So my y is going to move to 3. Okay, so my y goes from 1 and it goes to 3 because it moves 2. And my x's have to move 3. Okay, 1, 2, 3. So my new spot is now 3, 3. Okay, I just moved how my gradient was telling me. Now I have these 2 points and I can connect them, and that will be my straight line, okay, from my original function. So that is using the gradient intercept method. My other example is just using the dual intercept method. Let me do this example using the dual intercept method, okay? I'm going to move us back over here. Can we all see? Okay, cool. So if I wanted to do the dual intercept method for these, remember my example was y equals 2 over 3 plus.
No, these are the ones, the only ones.
You okay?
You know what? I don't know.
Sarah, are you talking to me?
No.
No, okay, cool. So we're going to use this example here, and we're going to do the dual intercept method, which means we need to figure out our y-intercept and our x-intercept. Cool, which means we're just going to let our x equal 0 and our y equal 0, and then we're going to find our 2 points. Okay, cool. So let's let my x equal 0, and we're going to get what we got last time. We're going to get y is equal to 0 plus 1, therefore y is equal to 1. So we get a 0, 1 as our 1 point. Is that visible? Kind of. Okay, cool. And then my next one, I'm going to let my y equal 0 to find my x-intercept. Okay, so then I'm going to get 0 is equal to 2 over 3 x plus 1. Okay, now I'm just going to work it like an equation. So I'm going to say negative 1 is equal to 2 over 3x. I want to get rid of my 2 over 3, so I'm going to multiply by 3 over 2. Multiply by 3 over 2. Multiply by 3 over 2. And I get negative 3 over 2 is equal to x. Okay, so my x-intercept, my x-intercept is going to be negative 3 over 2, 0. Okay, so if I wanted to plot those two, we have a Cartesian plane again. We have 0, 1, and we have negative 3 over 2, 0. Negative 3 over 2, 0. Okay? And our graph is a downward graph. Where did I just draw that? This one here. And originally when I tried to figure it out, that was the graph I got over there. Pretty much the exact same graphs. And if I was drawing this on graph paper, they would look even better. They would look exactly the same. Obviously, because it's the same graph, right? I'm just showing you a few different ways that we can figure out the same question. Okay, does anyone have any questions on that? So those are the 2 or 3 different ways we can figure out straight lines. Okay, I'm planning on doing one more example, just on something that a lot of people get confused with. Okay, so let me move us over to a new board and then we can start. Okay, here we are. Okay, this is our graph. Okay, when I write it, you might not think that it seems that difficult, but let's have a look. Okay, so g of x is equal to 5. Can you see that? Yeah, that 5 looks a little bit like an S, but it's a 5. Okay, g of x equals to 5. Okay, it doesn't look like a long one, but what is this actually saying? Remember, g of x is actually saying y equals 5. Okay, so let's think about what this graph actually is. It's going to be a straight line because there's no gradient, right? If there was a gradient, there would be something x, so 2x or half x, then you'd have a gradient. But now there's no gradient because there's no x's. And the coefficient of x is our gradient. So what we have here is a straight line. Is it vertical or horizontal? That's kind of like our choice here, right? We can either have a vertical one or horizontal. Well, before we draw it, let's just have a think, okay? What is g of -3 of this function? Normally we would sub a -3 as x, right? But there's no x. So g of -3 is equal to 5. What about g of 0? I'm going to sub in 0. What's that equal to? Again, there's no x's, so we can't sub it in. So it's still equal to 5. So that means for every single x value, so for every x value, our y value is equal to 5. So let's have a look at what that would look like if we were to draw it out. If we have a Cartesian plane, every x value has a y value of 5. Okay, which means it's a horizontal line. G of x is equal to 5. Okay, so this is obviously at the point 5. Okay, so when we have g of x or y equals something, it's a horizontal line. And we can use the information that we now know about how functions work and how function notation works to be able to just figure it out if we forget. Okay, so now, what is the domain and range of this graph? Okay, domain is all of our input values, remember, which are our x values. Domain, all of our x values, forever and ever get used, right? Yeah? So again, our domain is x is an element of the real numbers. Okay, because every single x value is going to get used. If I go x 1,000, y is going to be 5. Okay, so then we look at our range. Okay, our range. So normally our range is all the different y values that it can be. So for x equals 1, our y value is 5. X is -3, y value 5. X is 0, y value 5. So obviously, our only number or value in our range, I'm going to write it as a set, because normally when we write specific values, we write them in set notation, so I do the squiggly lines, and we get 5. The range is 5, because that's the only thing that it can be. It can only be the number 5. Okay. And then, if we had a graph that we wanted to write as a vertical graph, obviously we would just write x is equal to something. Say x is equal to 1. That means every time you put a y value in, your x value is going to be 1. Okay, so that was the last example I wanted to do with you guys. And then your homework is going to be 7.3 from Classroom Maths. Okay. Any questions, guys? Any questions from the homework yesterday or the day before? 7.1, 7.2, or was it all good? Anyone? No? Okay, cool. Yes, I am going to post them on YouTube, and then I'm going to put the links on Google Classroom. So they'll be available. I'm going to post them now, pretty much, or when I get home today. So it'll be up today. Okay, so tell your friends to come and watch, and encourage everyone else to do maths like you guys, because you guys seem to be the ones who are here all the time. So yeah, I'm gonna be posting them. Okay, anyone else have a question? I'm here to help you if you want me to go through a specific problem. No. Okay, cool. Then tomorrow we're having another Zoom, and we're going to be chatting about sketching more graphs. Okay, bye guys. I will see you tomorrow.